parallel measure of 315 degrees, and we want to convert that to radians, find a positive coterminal, negative coterminal, and a reference angle. So if we start by drawing that angle out, we always start with the positive x-axis and go around 90, 180, 270, and we'd end at 315 right there. Okay. So if we're going to start with this first problem and say, what is the reference angle? The reference angle again is formed by that terminal side and the x-axis. So how many degrees is in that full circle? And because it's in quadrant 4, this reference angle here is going to be 360 degrees minus the angle that we're using, so minus 315, and we end up with a 45-degree angle. So this is going to be 45 degrees when our angle alpha is 315 degrees, and so 45 degrees, that degree symbol there, that is the reference angle. Converting 315 degrees to radians, this is one of those angles that I mentioned would be helpful to start having memorized. Because the circle is broken up into equal 45-degree pieces, we have 7 pi over 4. Remember, 45 degrees is pi over 4, and so because we have all but 1, we've got 7 pi over 4. If you wanted to show that work, we can do 315 degrees times pi over 180, and simplify that to 7 pi over 4. Positive coterminals, because our original angle was given in degrees, to find a positive coterminal, we can take that 315 and add 360. And if you don't want to add 360, that's okay. You can add any multiple of 360. So you could add 720, 1080, any multiple of 360. Add, but 675 would be a positive coterminal. If you want to find a negative, again, you just have to do 315 minus 360. I believe that one gives negative 45 degrees, which matches that drawing. If you start with your initial side, negative would go counterclockwise, and that would have to be a 45-degree angle. Okay. 500 degrees. I already know that this one is going to be more than one full revolution because it's more than 360 degrees. So I might want to find, yes, I know it's going to be 360 degrees, but how many degrees more? So I could take my 500 degrees and subtract 360 to find out that it is the same as a 140-degree angle. It lies coterminal with 140. So after I do my 360, then I want to go 140 more. So there's my terminal side. If I'm going to find my reference angle again is formed by my terminal side and the x-axis. So my reference angle is going to be right in there. Well, if we already figured out that from here around to here is going to be 140 degrees, to find the reference angle, we can do 180 and subtract 140 and find a 40-degree reference angle. So that's going to be our reference angle of 40 degrees. To convert that into radians, we can do 500 times pi over 180. And when we simplify that, we get 25 pi over 9. Okay, the last thing that we haven't found yet is our negative coterminal angle. So I'm going to want to take this 140 degrees and subtract 360 degrees to figure out if I started at the initial side, how many degrees would I have to go to get back up to right there? Well, I would have to go negative 180 and then negative another 40. That would be negative 220, which you could also get by doing that calculation of 140 minus 360. Okay. Two more examples, very similar, except now we're given our initial angle, or our original angle in terms of pi. So 5 pi over 4. That's one that we should have memorized. Because that 180 degrees is exactly pi, we want to go another fourth of a pi. So another fourth of 180 degrees. It's going to end up right there. So there is our terminal side, which means our terminal side in the x-axis, that is going to create my reference angle right there. Well, because that's pi and because this is 5 pi over 4, I want to subtract to find the difference. So if I do 5 pi over 4 minus pi, I am going to end up with pi over 4 as my reference angle. Okay. How do I turn 5 pi over 4 into a number of degrees? 5 pi over 4, I have to multiply by 180 over pi. And I know those pi's are both going to cancel. 5/4 times 180 is exactly 225 degrees. You could have also done that by recognizing 180 plus 45 would also give you 225. To find a positive reference angle for this box right here, we want to take our original angle of 5 pi over 4 and add 360 degrees, but because we're using radians, we will add 2 pi. But I know that I can't add those as they are, so I'm going to turn that 2 pi into a number with a common denominator of 4 on the bottom. So I know that 2 pi is the same as 8 pi over 4. I can add those together and get 13 pi over 4. And a negative coterminal angle, take my original angle of 5 pi over 4, and I'm going to subtract 8 pi over 4 instead of adding it, and we end up with negative, should be negative 3 pi over 4. Okay. I would recommend pausing the video, trying this next example on your own. If you don't feel like doing that, I will go through the rest of those right now. 7 pi over 3, if we're going to use this as our original angle. 7 pi over 3 is going to be more than 2 pi, because 2 pi would be 6 pi over 3. So I know I've got a full 360 degrees. I have 6 pi over 3, and I need another third of a pi. So there's going to be 1/3 pi, or that's also 7 pi over 3. My reference angle is going to be formed by that terminal side and the x-axis. So if I have 7 pi over 3 and I subtract 6 pi over 3, I end up with pi over 3 as my reference angle. Converting that to degrees, we could do 7 pi over 3 times 180 over pi. And when I simplify that, I know my pi's are going to cancel, and so I can do 7 times 180 divided by 3, and I get an angle of 420 degrees, which makes sense that it would be 360 plus another 60. That looks about right, 420 total degrees. As far as a positive coterminal angle goes, because this is already more than one full revolution, I can take my 7 pi over 3 and subtract 2 pi. But again, I don't want to write it as 2 pi because I can't subtract those without a common denominator, so I'm going to write 2 pi as 6 pi over 3, which leaves me with that pi over 3, which we saw also with the reference angle. And then we can take that angle of pi over 3, and we can subtract 2 pi to end up with a negative coterminal angle. Again, I have to write that 2 pi, though, as 6 pi over 3, so we have a common denominator. And that gives us negative 5 pi over 3. And you look at that drawing, negative 5 pi over 3, there'd be 3 pi over 3, so it's negative pi. And then another pi over 3 and pi over 3, there'd be negative 5 pi over 3. And the last example is just another way for you to picture reference angles and how there's going to be more than one angle with the same reference. And so you only have to memorize that one triangle, that one angle with the reference angle. This example says, what are the four angles theta? By the way, this symbol is the Greek letter theta. So that 0 is less than theta, which is less than 360 degrees. Just so that we end up with the thetas between 0 and 360, and we don't end up with coterminal angles somewhere in the thousands or something like that. So that the reference angle for theta is 60 degrees. So we already know that one reference angle would be as if it's itself. So if this angle is 60 degrees, then that reference angle formed by the terminal side and the x-axis would be 60 degrees. Okay. We could also have it be drawn down here so that the angle formed by this terminal side and this x-axis would also be 60 degrees. Okay. So we've already got one angle, we've already got this 60 degrees. So theta can equal 60 degrees. It could also equal negative 60, right, if we go in the clockwise direction. But I can't write negative 60 because it has to be between 0 and 360. So I could take this negative 60 degrees, and I could add 360 degrees, and I would find that I could write that as 300 degrees also. So 300 degrees would be another option. Again, that would be starting at the initial side and going around counterclockwise. 300 degrees would get me to that same point. Okay. There are going to be two more. So it doesn't have to be necessarily just with that side of the x-axis. We could use this angle. This side of the x-axis. So if this x-axis and this terminal side form a 60-degree angle, then this angle here would also have a reference angle of 60 degrees. Okay. Well, because this forms a straight line, 180, we can figure out that that angle has to be 120 degrees. So 120 degrees is a third angle that would have a reference angle of 60 degrees. And the last one would be if we use, again, this x-axis, and it forms 60 degrees right there. So if that's a 60-degree angle, that would be an angle of 180 degrees to the x-axis plus another 60. So 180 plus 60 would be a 240-degree angle. So this list is not in order, but those would be the four angles that all have a 60-degree reference angle. The assignment for you to work on tomorrow in class is going to be page 245, 21 through 62, and page 246, 72 to 76.